Hello, everyone. In this third episode, we will be concentrating on more examples on how best we can apply the laws of limits to solve questions that pertains to radical functions, um, quotient functions, and some other interesting functions as well. But this time around, I would want us to extend it a bit more to include a situation where x may approach positive infinity. I believe this section is an interesting you do not want to miss. Thank you so much for your audience.
Hello. Yes, so we are back. But before we continue, I would want you to just, think about this problem. How do we solve this problem? Limit of the rational function x squared minus 9, all divided by x plus 3 as x approaches negative 3. Think about this and give me your response in the comment section, and I'll attend to that. All right, let's look at this problem. I would want you to note that this problem, we cannot just apply the rules of limit that relates to rational function directly. What am I saying? The theorem on limits of rational function does not apply immediately because minus 3 is not in the domain of given function. Do you see that? Because minus 3 is not in the domain of the given function, of the given rational function, we may want to simplify this function first before we apply the law that pertains to rational function. Am I clear? All right. So I would want us to simplify the function. Now, we see that the numerator of the rational function is a difference of 2 squared, right? So it means that we can write it as what? X plus 3 and x minus what? 3, right? Now we see that over here we can confidently do some cancellation, right? So when we cancel out, so you see that the denominator will cancel on the numerator, and that will give us x minus 3. Now, we already learned this law. This law is directly applicable. So what do we get? It just means that wherever you see, you just replace it by what? Minus 3. So we're going to have minus 3 minus 10. That gives us what? Minus 6. All right, good. So now I believe we are okay with this, with these laws. But I want us to look at a situation where x will not just approach a rare number, but rather a very large number. Let's call it infinity, a number that we cannot think about. Very large number we cannot even think. So we claim that number, such number is what? Positive infinity. So that's the kind of problems from this time on we want to look at, okay? Now, the question is, how do we solve such problems? When x is approaching a very large number that we cannot even imagine, right? How do we solve such problems? We are going to divide the numerator and the denominator by the highest power of the denominator. What's the highest power of the denominator? Anybody? What is the highest power of the denominator? So the highest power of the denominator is x to the power 2. Now, since x to the power 2 is the highest power of the denominator, we are going to divide every term in both the numerator and denominator by this highest power, which is x to the power 2. All right, now let's do some simplification. Now we see that these ones cancel themselves, right? So you're going to have 1 plus, and this will cancel the square here. So you're going to have 4 divided by x minus 5 divided x squared, and this also cancels that. So you're going to have 2. This cancels the square here. You're going to have 1 out of x plus 1 out of that, right? So from here, what can we say? So we said that, remember, when we're learning the law, the theorem on limit that relates to a rational function, we said that the limit of a quotient is a quotient of the limit, right? If that's the case, then we can apply it directly, okay? Otherwise, if you assume that you know it, what we can do is that we can switch in the limit on both the numerator and the denominator, okay? So the limit on both the numerator and then the denominator. All right, now on the numerator, what is the limit of 1? So the limit of 1 is 1 because we said the limit of a constant is a constant, right? Now, what's the limit of 4 out of x? So let me do a little bit of algebra here. So if I have, so we are looking at limit as x approaches infinity of 4 divided by x, right? Now, over here, whenever I see x, if I plug in infinity, it means that 4 is dividing remember I said that infinity is a very large number, okay? Positive infinity is a very large positive value, right? So if I divide 4 by any large, suppose the infinity is 100 or let's say 1,000. What do you think we will get? You're going to get 0.0004, right? What if it is the infinity is million? It means that this value will approach a very small number, which is almost like 0, right? So divided by a very large number will eventually approach zero. Okay? A very small number divided by a very large number will eventually approach zero. Okay, very good. So if you understood it, let's move on here. All right, so 4 divided by a very large number will eventually give us 0. 5 divided by x to the power 2. So if x is infinity, 5 divided by a very large number will eventually approach what? 0. Good. Let's come to the denominator, right? So what's the limit of a constant? We said that it's the constant. So limit of 2 is 2. What's the limit of 1 out of x? And that will eventually approach 0, and the other will also approach 0. So in the next, you're going to have 1 out of 2. So the limit of the rational function as x approaches infinity will be 1/2. I believe we all get it. But if you need, further explanation, you could put your question in the comment section, and I would address it as soon as I'm done with the discussion. Okay, so let's get one more example, then we pause over here. So let's find one more example. So if I ask you to find limit function, all right. So the limit of this rational function, since this question is related to the previous problem, we can just go directly, right? Which we can just go straight to the point, right? But then there's something I want us to look at. What did we say? So over here, what you're going to do first, we're going to what? You're going to divide the numerator and the denominator by the highest power of the denominator, right? Which is what? X to the power 3. So we are going to do the same thing over here. We see that the highest power in the denominator is x to the power 3. So it means that every term in both the numerator and denominator shall be divided by x to the power 3. So let's go. If that's the case, I believe at this point, everybody is understanding the concept very well. Good. So we are dividing each term. All right. So we're going to do some cancellation. So this cancel out that. This cancels this. This cancels this. This cancels one of these. So we're going to have 2 plus 5 at x plus, and then limit. All right. So now what's the limit of a constant? We claim that the limit of the constant is the constant, right? So the limit of 2 will be 2. And the limit of 5 out of x, we said it will be what? 0. So we said that 5 divided by infinity. Remember, infinity is a very large number. So 5 divided by a very large number will eventually approach 0, right? Will eventually approach 0. So we have 0 plus 0 minus 0, all divided by 3 plus 0 minus 0. So which will give us 2 out of 3. So guys, thank you so much for taking time to listen to me. Guys, subscribe, share the videos to your friends who needs help, and direct them to my platform, and they will never regret because I give the best. Thank you so much for being my audience.